Hello friends, I invite you to lecture 62 and in this lecture we will discuss a small case study using some of the concepts of Six Sigma. So let us begin with a beautiful inspiration. A key to achieving success is to assemble a strong and stable management team. We had seen this, and you cannot execute really the Six Sigma project, a case study we are discussing, unless you have the team which is really strong in terms of skill as well as the team management approach. So we had the discussion on various roles of the team members, team formation stages, communication and dynamics and various things we talked in detail in the lecture team management. Now we want to go through a small case study where some of the tools of the Six Sigma are applied to address a particular problem. So an observational study of manufacturing process of a telecommunication cabinet, door panel and implementation of DMAIC in order to reduce the defects. So please understand that whatever we have gone through was a full course on DMAIC, and I have discussed all sorts of tools and techniques, but not necessary that you will use all the tools and techniques for a given case study. You have to judiciously select that what is exactly required, and then you can try to suggest the improvements in the existing process. So we know that Six Sigma is all about achieving very high quality standard. 3.4 parts per million only should be rejected, and my processes will have very less variability and centric towards the target value or the mean. So Six Sigma is a DMAIC approach, and exactly we will try to apply this for the case study where we will try to investigate the particular problem. So the current case, the one which we will be analyzing, deals about the manufacturing of a telecommunication cabinet door, and sheet metal made of steel is used to manufacture the door. This door contains 2 padlocks and 4 hinges, and the finished door was sent to different unit for assembly. So it's a very simple component. It is a telecommunication cabinet door, includes 2 padlocks and 4 hinges, and then it is sent to the different stations for the assembly. So this is the picture, and you can see that this kind of cabinet you must have seen at various places. Now company had encountered some problem. So before we talk about that, they have some coding system, and the door panel had many dimensions to be measured. So obviously you cannot focus on all the critical to quality. You have to find out the one for which you will really conduct the DMAIC cycle, and the one which is causing the maximum customer dissatisfaction, either internal customer, your next assembly stage, or the final customer. So you have code 04 for distance between the studs in the top row of the door panel. You have code 06 distance between the studs on the right vertical column of the door panel. You have code 7 distance between the studs and the bottom peripheral edge of the door panel. You have code 8 distance between the studs and the right peripheral edge of the door panel, and code 12 distance between the top peripheral edge and the center of the first hinge. So in their own context they have defined the various measurements, various characteristics to be measured, and they have given a specific code. Now what has been observed, that among these distances, all these codes distances, code 12 at the maximum rejection, and this is shown here. So what we have done, we have used Pareto chart to see that number of deviations, this is the cumulative percentage, and what we found that when I go to, let us say, some 80%, it would be here, but if I just go by the number, then this one, which is code which is your code I think 12. So this is receiving the maximum defects. So this is your code 12 which is receiving, this is the dimension code 12, 7, 8, 6 and 4. This is receiving the maximum number of deviation, that is 30. So now you have a typical SIPOC. We have discussed in detail to map the process right from the supplier to customer. So the SIPOC for this is like this. You have the GI sheet manufacturer, this is the input, then process is punching, deburring, banding, welding and finishing. You have the output, finished front door, and customer is the telecommunication company. So this is what you can do in a very simple way. Now in the measure phase, this is the define phase. What is the problem? Now in the measure phase, so data for the measurement of code 12 was collected, and the data was for a duration of 18 days. So the equipment used by the quality inspectors to measure the data is a vernier caliper. We have to define all this, and the band of the sheet, a right angle scale to measure the degree of the band, a steel tape to measure the dimensions. So they have defined the instruments used and what they are measuring. Using this data, a repeatability and reproducibility study was done, and Minitab software was used for the convenience, and more or less say what you can find that gauge R&R is 99.53%. So I can say that my gauge is acceptable range, and the acceptable range is 10 to 30%. Since 99.53% is very far from acceptable range, measurement system is industry is very poor. So this is something that I can reveal from the gauge R&R. It may be because of instrument error or it may be because of your operator error, but you have gauge R&R 99.53. So usually we accept up to 10 to 30%, sometimes even 20%, but it is too much high and there is a problem. So at least one thing I have identified in the measure phase, that what could be the problem at this stage. The result of the measurement system analysis reveals that measurement system has to be improved. So now there is a problem with the measurement system itself, and otherwise it will follow the GIGO, garbage in, garbage out. So process capability analysis was also done, and this says that CP/PP are greater than 1.33, which is a good performance, but the overall measure is CPK is 1.3, which is little bit less than the 1.33. So here you can be little bit skeptical. You may go for little bit process improvement, or you can go ahead and later on you can see that whether your mean shifting is really taking place or not. So current sigma level was found to be 3.49 and costed you something around 3450 per panel. So this is what I have done in the analyze stage. Now you can see my CP. So you have CP diagram, and CP is 1.54, CPL is 1.79, 1.3, 1.3. So not too much problem with the existing process, maybe a marginal difference, and if there is a need in future when the CP value really goes down, you can really say intervene and take the corrective action. Subsequently, say I have also plotted the X bar and R chart. So this is my X bar chart, this is my R chart, and what I can see here that some point on X bar chart is falling below the lower control limit, some point on the R bar chart is falling above the upper control limit, and this could be a problem or point of concern specific to sample number 15. So if you are setting the trial control limit, you can eliminate this point and set your this thing. If you have already well established limit, then you try to take the corrective action in order to say get rid of an assignable cause and bring the process back to the control. So now improve stage, we are trying to say conduct the cause and effect analysis to depict the causes for the errors and to find a suitable solution. So a brainstorming session was conducted to decide a main cause for the error, and fixture was primarily cause for the variation in the code 12. So we had the problem with code 12, maximum number of defect. We had also seen there was a problem with the measurement. We had seen that sample number 15 was indicating out of control process. Then we did the cause and effect detailed critical thinking analysis, and it was found that the fixture is a problem. The fixture had a rectangular, say, through pockets where the worker places the hinge and welds it to the door. So this was the situation of the fixture, and when the fixture was placed on the panel during welding, slight movement in the fixture caused the position of hinge to be altered. So you see that somewhere there was a locational problem, that where you are placing the fixture and what it does with the movement, hand movement of the welder, and this creates the problem. So then it was decided to weld an extra piece of metal sheet to the fixture. This improved the length of the fixture and used to clamp tightly to the panel. So there was some shakiness, and this was removed by fixing an additional sheet, and the problem was little bit, say, addressed. So improper hinge position was the problem identified, and then cause and effect was conducted. Personal carelessness, lack of skill, uncomfortable outfit, material may be, say, uncleaned surface, measurement, instrument error, human error, environment, maybe distraction, noise, temperature, method, pre-removal of arc gun, non-standard procedure, and machine, fluctuation in voltage, and so on. So many things were thought as a part of critical thinking, cause and effect, and the appropriate action is taken to put an additional sheet to make your, say, welding position quite accurate and the hinge welding stable. Finally, in the control phase, the solution was implemented and checked for the performance of the process. As a result of improvement, and the improvement showed that workers were more comfortable to weld the hinges. They were having better hand control. So with this new fixture or additional sheet, they were more comfortable and hand moment variation was reduced. So the sigma level increased to 3.67. Still we are far away from 6 sigma, but still there is some improvement in the sigma level, and it's an indication that my DMA IC cycle has operated well with some simple tools selected from the overall toolkit of my DMA IC, and it has brought some improvement for the case industry. So finally, results and conclusions were the percentage of total rejection in DPMO reduced to 15,873 from 23,271. It's a significant reduction. The decreased rework has a investment percentage from 1.6% to 1.12% with a magnitude of 0.48% per $1 million door panel produced. The sigma level increased 3.49 to 3.67. I will say it is just marginal. They also need to look into the other factors they identified through cause and effect, but there is at least some improvement in the sigma level. The design of experiment is conducted with varying levels of factors such as fixture design, welding machine level, and the performance can still be improved. This is what is recommended by the Six Sigma team. So think it. I am just giving you the open-ended question. Can you develop a blueprint for implementing DMA IC for a case organization, and can you replicate the steps, just the simple steps indicated in the case study for a manufacturing or service company of your choice, and conduct some DMA IC analysis? So you can refer a couple of cases from these books also, and DMA IC is a systematic methodology to bring the improvement on fact-based management in the process which is producing more number of defectives. So thank you very much for your interest in appreciating this particular case study, and you can extend a particular case by using the different tools and techniques we have discussed. hypothesis testing, ANOVA, design of experiment, and many others, and you can really get into the depth of the case problem and bring the significant substantial improvement in the sigma level for a company. So please keep revising, introspecting through application. Be with me, enjoy.